Macholo, my lecture of Industrial Electronics N3. Topic of today is chapter 1, the direct current theory. Before I can start with the content of it, let's remind you about the direct current of Industrial N2, where we use Ohm's law to calculate the unknown current. How is different with Industrial 3? With Industrial 3, we are no more using Ohm's law because with Ohm's law we use it only when we have 2 or 3 resistors. But now in Industrial 3, our circuit diagrams is where we use bridge, it's where we use the T circuit diagrams. So we are going to use the theorem that's called Kirchoff's law. In the Kirchoff's law, we have 2 laws. The first law, which is always representing the current, and the second law, which is always representing the voltage. As a student, you must be able to state those 2 laws. Where the first law, when we say the current flowing towards the junction is equal to the current flowing away from the junction. And you must be able to explain that also graphically by using some circuit diagrams. So as we say, we have a junction. We say the first law as representing the current flowing towards, no matter how many currents you have flowing towards. Towards I have I1, I2, and I3, and away I have I4 and I5. And I say they are equal. I1 plus I2 plus I3 is equal to I4 plus I5. How can I understand this better? By using the circuit of a parallel circuit. What happened in parallel circuit? When you draw the parallel circuit, no matter how many currents are connected in parallel, it's where we are going to have, let's name our resistance R1, R2, and R3. We have our supply here. What happens in parallel circuit when it comes to current? The current will split according to the resistance. We have I1 here, I2, and I have I3. What do you mean by those splits? From the supplier, I always have the I total. Meaning my only I total is equal to those drops, which is I1 plus I2 plus the I3. When I add the 3 currents, it must give me the I total. It's what is meant here. Current flowing towards is equal to the current flowing away. No matter how many do we have towards, no matter how many do we have away. So this is how you show the first law, Kirchoff's law, which is the current law, when you state it. Current flowing towards is equal to current flowing away. What about the second law? With the second law, we are talking about the voltage. The voltage, we say the voltage drop in the closed loop is equal to the EMF. So graphically, we are using the series circuit. In series circuit, it's where we have the volt drops, no matter how many resistors are connected there. So name your resistor R1, R2, and R3. Then we are going to have the volt drop of V1, the V2, and the V3. So we say the V total is equal to V1 plus V2 plus V3. When I add my 3 voltages, it must give me the V total. So here we are explaining the Kirchoff's second law, which is the voltage law. So with those 2 laws, we are going to apply them to find the unknown current from our circuit diagrams by using the first law. Now let's check the circuit diagrams. If we check the second diagram, what is important that learners must know when we are going to deal with the calculation, when we are going to find the unknown? First, learner must be able to label the second diagram. As you see, my second diagram is labeled A up to G. Secondly, you must have the equations of your current flow. But if you check here, I have some unknowns. So learner must be able to find those unknown equations. Then you have to know how to divide your circuit diagrams. If you are going to find 2 unknowns, you must have 2 equations. If you have 3 unknowns, you must have 3 equations. So we are going to use loops to draw our calculations. But before we start with our calculation, now let's find our unknown equation. Starting with this one. If we check there, I don't know the equation there, but I'm going to apply my first law to find that equation. Now, which junction I must use? To find the unknown equations, we are going to use junctions. So which junctions I'm going to use? I'm going to use junction B. Why junction B? Because the current flowing towards junction B, I have 2 knowns and 1 unknown. So I will be able to know the one that is flowing there. Now I say current flowing towards is equal to current flowing away. Then you check according to the arrow which one is flowing towards B. This is towards, is carrying a positive, it's 0,062 amps. And this one is also flowing towards. I name it according to the resistance, it's plus IR2. This is flowing away is equal to I2. Remember we say current flowing towards is equal to the current flowing away. So what I need is IR2. I have to make that subject of the formula. Therefore, my IR2 is equal to I2. If I take this to that side, it becomes negative 0,062 amps. So here, the equation is I2 minus 0,062 amps. I'm finished with that one. Now I'm coming to this one. Which junction can I use to find this unknown equation? I can use H, not F, because F is going to have two unknowns. So it's better if I use H. Then the question will be, which current flowing towards and which current flowing away? Remember, the one flowing towards is equal to the one that's flowing away. So now we check which one flowing towards. We have I2 is positive. Also we have plus I1 is also towards, and away we don't know. We name it according to the resistance IR4. So it's already subject of the formula. Therefore the equation here is going to be I1 plus the I2. So I only left with this one. So with that one also, which junction can I use? I can use D because now I have that one, or I can use E because now I have F. It's depending on which one you prefer. Let's use D. Which one is flowing towards? Is this one? We name it according to the resistance. It's positive. Away is minus I1, and also away is minus into. Make a bracket because the negative is changing the equation. It's going to be I2 minus 0,062. Now you have to remove the brackets. It's minus I1 minus I2. Negative and negative is giving positive 0,062. Now let's put it in the correct way. It can be 0,062 minus I1 minus the I2, because this was flowing towards. That is how we find our equation. Then we write 0,062 minus I1 minus the I2. Now I find my equations. I can divide my second. You are the one who have to choose according to your understanding how you can divide the second. For me, I can take this half and this half. You're still correct. Or I can take this one and that one. You're still correct. Or I can take the outer and half of the second. It's your choice which one you prefer. So to make it easier, we can take half and a half, and again this one with that one. Sometimes examiner give you loops. Sometimes you have to do it yourself. But it's easier if the examiner give you loops. So let's give ourselves loops. I take loop A, B, H, F, G, A. I take A, B, H, F, G, A. So now you say the ET. You check if it's going to pass through the supply. We'll come to that. Now we check. From A to B we have 0,062. It's from where? The resistor R6. So we say 0,062, we multiply it with resistor 6. Check the flow of your current if it's follow. If it's follow each other, you add. If they're acting opposite, you subtract. So now it is follow each other. Our I2, now we say plus because it's follow each other. Our I2 is multiplied with the R1. And we have plus because they still follow each other. Our R4 is multiplied with I1 plus the I2. Now we have to remove the brackets. You ask yourself a question with ET. Is passing through the supplier? No. If it's no, then here it's 0. Now you multiply 0,062. You multiply it with 5 ohms plus R1 is 2, I2 plus R4 is 1 into I1 plus I2. So here if I have to remove the bracket, it's I1 plus the I2. Here is 2I2. It's plus, you multiply there, it's 0.062 times 5 ohms. It's still 0. Now we are looking for like terms. Here is it, once we look for like terms, I2 and I2, 1 plus 2 is give us 3. If you have a constant, you take it to another side. So it becomes negative. 0.062 times 5 ohms is equal to 2 plus 1 is 3I2 plus 1I1. So this we call it equation 1. We are finished with that. Now selecting another loop, let's take this half. So another loop, it can be loop. We can take loop B, C, D, H, B is ET. Check if the flow of current is moving together with your loop. It's BC, but the direction of the current is opposing it. If it's opposing it, you start by a negative. So here is negative R2 into I2 minus 0.062. Check if it's follow. The direction is here is follow. Then we have plus. It's R5 I1. But now here also is opposing. Then it's minus. It's minus is R1 I2. Now let's remove the bracket. It is passing through the battery. Yes. How much is our battery there? Let's check first how much it was given. It's 20 volts. So here we have 20 volts. Then we say 20 volts. And it's very important to check the direction of your current, how it's flowing. So here we have, remove the bracket. Your R2 is 3, negative 3. You multiply here. It's going to be negative 3 I2. Negative and negative is positive. 3 multiplied by 0.062 plus, for I1 here we have the value of our R5. It was given as 4. Here we have 4 ohms. Then it's going to be 4 I1 minus. Then we have 2 I2. Once you obtain a constant, you take it to that side, it becomes negative. It's 20 minus 3 multiplied by 0. Okay, let's make a bracket so that you can see the multiplication. 0.062 amps is equal to minus 3 I2 plus 4 I1 minus 2 I2. Also looking for like terms on that side is minus 3, both are I2s. Then we have 4 I1 minus 5 I2. So after you find values here, the side after you do a calculation, this we call it the equation 2. If you have the first equation and the second equation, you have to think about spontaneous equation, where you must eliminate either I1 or I2. Choice is yours. But now we can say, let's try to see if you can eliminate I1. Then you compare your I1. In equation 1, my I1 is 1. In equation 2, my I1 is 4. Meaning to make it to get 0, I have to multiply my equation 1 by how much? By 4. So that my I1 both are going to be 4. So that when I subtract, I must get that 0. I'm not only going to multiply I1, I have to multiply the whole equation. So to multiply the whole equation, it will be 4 into minus 0.062 times that 5 is equal to 4 times 3. It will give you 12 I2, and with I1 it will give you 4 I1. This we call it equation 3 because it's been changed from the original. Compare it with this one. Here I have 20 minus 3 into 0.062 amps is equal to I2 under I2 and I1 under I1. So minus 5 I2 and plus 4 I1. This is equation 2. So you ask yourself a question. To get 0, when you compare your I1, what must I do with equations? To get 0, because both of them they carry the same sign are positive, then I have to subtract to get 0. Meaning you will say equation 3 minus equation 2. Then when you subtract after multiplying, and you are going to left only with this I2, where you will say 12 minus 5, then it's going to give you 17 I2 on the side. Is 12 minus 5, this side you get 17 I2. This side I don't have a calculator, that's too bad, but you can multiply and see if you subtract, multiply get the answer, and multiply get the answer. When you subtract, then we will know how much you get there. Then to get I2, you will divide by 17, and also here divide by 17. Therefore, you'll be able to find how much is your I2. After finding I2, you take this and substitute in equation 1, the original, not after multiplying by 4. The original is either I1 or I2. If you take I2, here you still have that value. It will be 4 is I1 minus 5 I2. So when you see I2, you will substitute by the answer that is there, that you find it there, and you'll be able to find I1. After finding I1, therefore you will compare, or you will add. If they say find I3, then you will get how much it will be. So this is how you are doing your calculation by using Kirchoff's first law, by using loops, finding the unknown curve. It's too bad I don't have a calculator, therefore you will calculate for yourself.